much blank page.
And there's kind of a phrase at the top. Look at those letters and what it means. Four, six is what you're doing, right? Oh, 4, 7 is one that we aren't doing. Let's see what it is, maybe indirect proof or something, but it's not a section we'll cover. Okay, we're going to use CPCTC to prove parts of triangles are congruent. So as you look at your notes, what does CPCTC stand for? What's the first C? Corresponding. Corresponding parts of congruent triangles are congruent. You need to learn that phrase. That's like a theorem, idea, actually definition, okay, in shortened version. If you remember the day we first started talking about congruence last week, we looked at all the corresponding parts, the matching parts, and on triangles we had to get 6 sides congruent, pairings of sides that were congruent, and, 3 pairings of sides that are congruent, and 3 pairings of angles. 6 total pairings is what I was trying to say, congruent. And that was the definition, that if all the corresponding parts are congruent, then the triangles are congruent. We're going to kind of use that in the reverse. Definitions can go both ways. If 2 triangles are congruent, then all their corresponding parts are congruent. And we're just abbreviating that by saying corresponding parts of congruent triangles are congruent, CPCTC. So this is an abbreviation for that phrase, which is basically stating the definition of congruent polygons, or specifically triangles, just in a memory phrase, in a shortened version, so that we can make it more convenient to write. We're going to use it in a proof after you get 2 triangles congruent. Because listen to the phrase again. Corresponding parts of congruent triangles are congruent. Doesn't it say that you have to have congruent triangles? Corresponding parts of congruent triangles are congruent. So kind of like if there's corresponding if there's congruent triangles, then corresponding parts are congruent. That's the if-then form of this little memory phrase. Okay? All right, so let's say that phrase 3 times so that we start memorizing it. If you need to, read the board. Okay? Go. Corresponding parts of congruent triangles are congruent. Louder. Corresponding parts of congruent triangles are congruent. One more. Corresponding parts of congruent triangles are congruent. That's your phrase for the day. It's going to be on the test. So where do you use it and how do you use it? Well, this is kind of the structure of what we've been doing. Let's say we're going to prove 2 triangles congruent. We'll make it easy by side, side, side. So for instance, we might have segment AB congruent to segment XY for whatever reason. We might have segment BC congruent to segment YZ for whatever reason. We might have CA congruent to segment ZX, I think it would be, for whatever reason. Maybe those are all given, maybe it was reflexive, I don't know. But what would be in this oval based on side, side, side? Yeah, and if I matched them up, that's probably the right way. Okay, so now we have congruent triangles. So what can we still come up with? What corresponding parts of the congruent triangles are congruent that we haven't mentioned yet? Page? Supported by CPCTC. Angle B is congruent to angle Y because of CPCTC. Angle C congruent to angle Z, I think, CPCTC. So we have 3 things that get the triangles congruent. Now we'll have 3 things we could use after it. We won't use all of them in a proof, but we'll probably use one of them. And then maybe we have to do something more with it, but to get from the triangles to something more, we're gonna be using the CPCTC. Corresponding parts of congruent triangles are congruent. So that's kind of the order that things would happen. Oh, don't, I don't know if I'm gonna have it, it disappeared. Oh, right, it's still there. I did what? You want good notes? I need to be patient enough for you to write them down. And the reasons on those top ones might, if you want to put a reason, just put given, or I guess none of them would really be reflexive. Just put all those as givens up at the top, I guess, if you want to. Right now? All right, so thanks for stopping. All right, so again, in summary, these 5 relationships get the triangles congruent. CPCTC gets parts congruent from the congruent triangles. So it's like they're converses. You get the triangles, you get after the triangles. Okay. Let's put it together in some thinking, and then we'll do a couple proofs. It says a landscape architect sets up the triangles shown in the figure to find the distance of JK across the pond. So we're trying to find this length. What is JK and how can we come up with it? Can we get those to be corresponding parts of congruent triangles? Because if so, we'll be able to tell what the measurement is. Can you get the 2 triangles congruent? Give me something, Nathan. Sides or angles that you know congruent? And you're just looking at the measurements, right? Yeah. All right. Tina.
JLK and MLN are congruent.
Triangles or angles?
Angles.
Angles, reason?
Because of the vertical angles.
Okay, so he's giving me this is congruent to this. Okay. All right, what do we know now? Paige. I don't think you matched it in the right order. ML, yeah, we would want KLJ. KLJ, reason? Side angle side, congruence postulate. Now is when you would use CPCTC. So what parts are we interested in to answer the question? We're interested in JK. What's going to match with JK? MN? Okay, so we would be able to say segment MN is congruent to segment JK because of CPCTC. And then looking at the picture, we'd be able to say JK equals 41 feet. 41, I guess I shouldn't put that. 41 feet because they matched up. So the idea is to get them matching parts in the congruent triangles. So that was a thinking through, kind of scribbled a little bit as far as your reasons. I don't know why I went out completely. Okay, go back into it. All right, let's get back to where we were. I must have hit too far up or something. Okay. So let's do an actual proof. You've got a lot of blank space on your paper. Yes, you do. There's the front and the back to it. Your setup. All right, so given the PR bisects those 2 angles, prove those segments are congruent. As you're writing it down, do you notice that what it says to prove is not 2 triangles congruent, like all the ones we've been doing recently? We're going to come up with segments congruent in the end. Perhaps we go through getting triangles congruent, so that those two segments are matching, corresponding. I think before I start writing, I'm going to realign my smartboard between yesterday and today. It's off a little bit again. Well, once you get it written down, you can think about, okay, can I get the triangles congruent and how? That's what you were doing on yesterday's assignment. So you can start in. If you and I don't write it exactly the same, we're probably okay. We're going to both try and get the triangles congruent. Realign it. Okay, hopefully that's better for me. All right, so what's something you're starting out with? You got the given for the first line. Does given have to be the first line? No, but at least it's a starting place. Segment PR bisects angle QPS and angle QRS, given. Riley, do you know what should come next?
Segment PR is congruent to segment PR.
Okay, correct. Somewhere in here, segment PR congruent to segment PR. Do you have a reason? Reflexive property of congruence. I might have put that in a little bit later, but it needs to be in there. Why would I have maybe put it in later? I probably would have thought about the given I had written down and then go in sequence with that. But since you gave it to us, we'll put it in there. Now let's think about what that given tells us. What's it mean if that segment bisects the angle? Okay, so can you pick up a pair of angles for me that are congruent? QPR. It's congruent to angle, what'd you say? RPS. Did you give me the reason? Okay, good. Definition of angle bisector. Okay, so she bisected angle QPS. Who can do the similar type of thing for angle QRS? Zach, are you with me? Can you tell me what angles are congruent? If you bisect the angle QRS?
Angle QRP is congruent to angle SRP.
Oops, I said put D, P. And reason? Right. So if you wanted to put those last two in the same number, you could. There's a lot of numbers, so you don't have to. QPS. Okay, updated my picture. Okay, where are we at in our thinking? Number 5. Tina?
The triangles are congruent due to angle setting.
Okay, can you tell me how to write the triangles? If I call the first one triangle PQR, how should I list the second one?
PSI.
Yes. Yes. And what did you say the reason was?
Angle side angle.
Okay, question about angle, side angle? Two angles and the side that hooks them together? Okay, now that's not what we were supposed to prove. That's how far we got yesterday. So what are we looking at using after the triangles are congruent? CPCTC is what we're thinking we can use. So our segment PQ and segment PS, corresponding parts of what we have at line 5. Segment PQ, congruent to segment PS. Yes, they match up. So they are corresponding parts of congruent triangles. So my reason is going to be they're corresponding parts of congruent triangles, so they're congruent. So I'm going to say segment PQ is congruent to segment PS. So we got beyond the triangle. Thumbs up or down? That will go. All right, looks pretty good on that one. All right, can I get rid of this screen? All right, let's do another one. I think I had it in flowchart form. All right, here's another one. We're practicing for your quiz anyway because you have to do proof and thinking, side, 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 and all that. All right, let's think what we're given. How can we get angle x, y, w congruent to angle z, y, w? If it told us there was an angle bisector, we'd have it right away, but we're bisecting a segment in the directions, not an angle. While you're writing, I'm going to write the first part of the given as line 1. Okay, what's it mean when we think about and interpret that first part of the given? If segment YW bisects segment XZ. Does that give us congruent angles or segments, and what are they? Page? Okay, it will give you congruent segments. Can you name which ones they are? Okay, segment XW is congruent to segment WZ. And what was your reason? Definition of segment bisector. Update the picture. Those two are congruent. Next one. Here.
Segment X, Y is congruent to segment YZ. That's equal.
That is given. Do we have the triangles congruent? Not yet. What do we need to put in here? Nathan? Segment YW. We want to segment YW. Reason? Yep. Reflexive property. You never knew that we'd use reflexive this much when we first talked about it, did you? Reflexive property of congruence. Are the triangles congruent yet? Yes. Okay, so Kenneth, what do I need to write?
Triangle
This reason? Side, 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 congruence postulate. But that's not what it said to prove. Is this angle, which would really be angle Y in that first triangle, is that congruent to the angle Y in the other triangle? Angle Y in this one, angle Y in that one, looks like they do match up. So Brendan, what's our last line?
Angle x1 w
What's CPCTC stand for? What's the first C? Corresponding, okay, the whole thing. Corresponding parts of congruent triangles are congruent. Okay, question on that one. Okay, let's squeeze one more in because I think the ending of it is different. Do we have to just go that one step after the triangles? No. This one's going to have more than one step after the triangles are congruent. Because notice what we're trying to prove is two things parallel. CPCTC does not support two parallels. It says they are congruent. So we can get something congruent, but not something parallel based on CPCTC directly. So this one ends a little bit different. I would say put it on your notes. For notes down the back side maybe. I think it'd be good to have it to look at, for example. instead of the whiteboard. J is the midpoint. Of segment KM and segment NL. Okay, we need to interpret. What's that mean? John, what's that mean?
That bisects KM and NL.
Okay, tell me a little bit more.
Makes it into two congruent segments.
Okay, what segments?
NJ is congruent to JL.
Segment MJ is congruent to segment JL. Should we do
And-
both of them? Okay, and
should
segment
we- KJ is congruent to JM.
J is congruent to segment JM. They're the same reason, aren't they? That's our reason.
Definition of a segment bisect.
That's not what it says there is.
Oh, definition of midpoint.
Definition of a midpoint. I'm going to update my picture. MJ congruent to J. Oh, that wasn't stated right. MJ is not congruent to LJ. Is it? MJ would be congruent to KJ. I don't know if I wrote it wrong or if he said it wrong. So what's the other one? NJ congruent to JL or LJ. So two markings there, two markings there. Did you say it right? I just, you think so?
I meant to say M.
I might have just written it wrong. Okay, now, what triangles are going to help us? Because couldn't we get a lot of triangles congruent using vertical angles? We could either do the ones on the left and the right, or the ones on the top and the bottom. So let's look ahead. If we're trying to get KL, I'm trying to get this one parallel to this one, KL and MN. So let's pick the triangles that would help us eventually get to the parallels. So I think it needs to be the top and the bottom one. So, okay. Angle LJK, is that the top one? Congruent to angle MJN. And the reason is vertical angle theorem. So we picked that angle and that angle is the ones that would help us. Do we need to say the others? No, not unless they're helping us. Okay, right now we have two triangles congruent. Are you with me? Okay, so triangle, I'm going to call the top one KJL. congruent with triangle. KJL goes with what? Somebody's Siri. KJL with what order would the other one go? I don't think it would start with N, because if I put NJ, that would match with KJ. That's not the way I want it to match. MJN. So that would be the order. You got shut off now? MJN. Reason? Side angle side. It is important that you list them in the matching order, otherwise your CPCTC statement isn't gonna match right. So now, what out of those triangles will help us get the lines parallel? What things concluded, then the lines are parallel? Those were those converses of like corresponding, alternate interior, alternate exterior. What would help? Well, I think it could help if I had this angle congruent to this one, or the other way, just one of those, because if I can get this angle congruent to that one, I can use the converse of alternate interior angles to make the top and bottom parallel. Okay, so is the angle K in my first triangle matching with the angle M in the second? K with M, yes. So those are CPCTC angles. I can't just say angle K though, so I've got to do the 3 letters. So line 5, angle. You want to go JKL, congruent to angle, oops, not the triangle, angle. JMN, reason? CPCTC. We're not done there. But can't we now say segment KL would be parallel to segment MN because of, no, not CPCTC. That says they are congruent. What says, once I know this angle is congruent to that one, that the lines are parallel? What supports the parallel lines? Some kind of converse. Which one is it based upon those 2 angles? Alternate interior. So converse of alternate interior angle. So notice how that one did not stop with CPCTC. So you could do some other things. You've got to think, now what corresponding parts will help me do what we're trying to finish. All right, so with those examples, let's write down the problems. They're out of the book this time. $262. A lot of single problems. Make sure you write the correct ones. And a fair number of them are odd for you to get some help if you need to. This would be the last section that we're covering in the chapter, so tomorrow we'll review and Friday's your test. So do make sure that you're getting the knack of these proofs. Okay, the quiz that I have for you is fairly short. I think it was 11 problems. So not real long, but should give us a good idea if you understand these.
Miss Frank, I was sick.